Hi and welcome to this Fusion 360 cam tutorial. I will make this vacuum pad today that I will show you how I make the cam feature, and then on the machine I will also show you how that looks like. So for an example, we're going to make the bore, and subsequently I'll show you how the bore looks like when we route it on the machine. The plate is made of POM or Acetal, also called Delrin, and it machines very well if you use an O-flute bit. There are two different tools I use, and I leave you the links in the description. Next, I have three really awesome tips. One is I'm going to show you how you can synchronize your view cube with your setup, so you don't have to fight that all the time. Second, I will show you how Fusion 360 can track the stock throughout your setups. And third is that during simulation you never see a tool holder because there is no ER20 tool holder for our spindle in Fusion 360. But we can make one, and then it will also notice when there is a collision, or it can notify you before you make a collision. Okay, let's get started.
Let's have a quick look at the model. So we just have one body, and then there is the vacuum pod, I called it, itself, the drawing of that or a sketch of that. Then the feature for the hose right here, which actually I'm not going to make in this cam. This is something I'm going to drill by hand. And then the vacuum channel itself right here. Then there's a center hole that you see here. And that center hole is also a portion of the cam. Okay, then next we need to go from design to manufacture. Okay, setup, new setup. Default is that we have here the XYZ in the origin, in the center. And I like to place it at the bottom because that is where I zero out on the table. I don't zero out on the top of the part. So the first challenge will be to put the coordinate system into the work coordinate system here into the right place. So we have to use a view cube, turn the whole thing around, and then we'll see that we get it into the left-hand corner right here, the lower left-hand corner, this one. So we have a stock box point right here selected, and I can select that now, and I'm gonna for fun do it, but it's gonna move it around, but maybe that is also something to show. So we have here model orientation as for the work coordinate system, and that is wrong. We need to choose two axes. Actually, I like to select the X and Y axis so that I can choose the correct axis on the model itself. So it wants me to choose the X axis on my machine. It will be this line right here, and it moved it to the right hand corner. I ignore that for the moment, and now it wants to select the Y axis, and the Y axis is this one right here, this edge. The origin is the stock box point. The stock box point is correct, but now we need the correct point, and that is the lower left-hand side right here. And you can see it's still the wrong way. X and Y are correct. Z, as far as the axis goes, but it's the wrong direction. So I can flip X by clicking on X. I can flip Z, and now I have it the way I need it. So X, Y, and Z, sometimes I just, step at this until I have it the way I need it. And this is correct now. This is what we want. Let's go to the stock. So we have a relative size box that's default. By the way, you can change that default setting up here as well. But anyways, I'm going to have a fixed size box. And when we do the fixed size box, we usually round up to the nearest 10 millimeters. So I'm going to right away set that to 0. I don't want to round anything. And I hit enter by accident. If you do that, just right click, edit one more time, back to stock. And the width is 124. The material is in the center, 124 for Y as well. and then it is 16.3 for the Z height, and also in the center. Okay, that is actually what we need to do on this tab. I'm going to click OK. And now we can start with the first operation, and that is to face this side off. Pay attention to the view cube up here. This is where I'm at right now. You will see that it is actually upside down, and it's going to make a problem. And I'll show you a trick in a moment on how to fix it. Okay, so 2D, there is a button right here for the facing operation. Let's hit that. And the first thing you want to do is select a tool. So I have a tool in the library already. On the right hand side, you basically just can select face mill as a filter. And these are the face mills that I have. And there's an Amana tool come up. This is here, number 9 actually. Okay, I'm going to select that. There are some default settings down here, 12,000 RPM, 1.5 meters per minute. Hey, for plastic, that sounds right. Okay, so let's select this. And the next is that we have the coolant disabled. That's correct. I just double check and glance. All of these values right now look good to me. The geometry is something for the facing that Fusion is really good to know what that is. You don't really need to do anything with this tab. The heights, you could leave this. I normally change all these values though, because 10 millimeters for the clearance height for the stock top, and then 5 millimeters for the retract height. That is just too much. So I'm going to do 5 millimeter for the clearance height, and then the retract height is going to be 3 millimeters. The feed height is going to be from the top height. Well, wait a minute. What is the top height? The top height is the stock top. Okay, I'm okay with that. So from the stock top, we're saying the feed height will be 5 millimeters. That's actually more like 2 millimeters. Okay. And then the top height is a stock top, and the bottom height is your model top. That is also correct, because you can replace these two words that you get confused with it. Top height and bottom height, replace them with where do you want to start your toolpath? What is your starting point in the heights? Well, that's the stock top. And how far are you going to go down actually? Well, I'm going to go all the way down to the top of the model, and that it says right here, model top. Okay, then we have the passes, and I like to select a path direction reference. So I just click select, and the reference will be here, the y-axis. I like for the tool to go forward and backward in this picture so that it uses the stronger y-axis on my machine because it has 2 motors on it. Okay, so next is it's going to go in both directions, both ways. That is correct. And I like to choose multiple depths. Now, for this cut, we don't need it, but I like to show you how to set up. I like to have a finishing step of 0.2 millimeter that I already put in here. And the reason is that the finishing tool itself, I like always a good surface, and the final step down with 0.2 millimeter is going to achieve that. Now here we are only taking off about 0.6 millimeter altogether. It wouldn't make a difference, but I like to show you, let's say we make a 1 millimeter cut up front, and then I would follow up with a 0.2 millimeter. There's no stock to leave. Next step is the linking, and there isn't really anything right here for this facing operation that we want to do or need to do. I'm going to click OK. All right, we start in the front left-hand side. I like it. Let's simulate this toolpath. And the first thing I like to show you is that there's probably something different on my screen than on yours. And that is that I have the tool, but I also have the representation of my spindle right here. And the reason for that is that the ER20 tool holder does not exist in Fusion. So I'm going to come back to that in a second. Let's go ahead and simulate this. There we go. First pass and second pass. I'm going to exit the simulation, show you how to add the ER20 collet. So you're going to go into your tool library up here to your local library. I already have holders selected now, but let's say that holder is not there yet. Then you're going to say add up here. And now instead of adding a tool at the very bottom, you can add a holder. All right. Let's say I'm going to add a holder. So there's a general description. You could put in ER20 and so on and so on. But then there's the holder geometry, and you see this is just empty. And you would click plus right here. And then there is a field come up. And this field just represents X and Y directions with the diameters. So I'm going to show you the holder that I have. That is this one right here. It's the ER collet and the holder geometry. So there is 5 elements to making the drawing on the right hand side. And you can pause here if you like and then copy these values and then just make your own. I'm going to hit cancel and back up to the drawing. Let's simulate this, and we can see that we are down to the model because the model itself turned green, and we can see the stock left around it. Okay, next is that we are going to face the top side in the very same manner. But therefore we need a new setup because our work coordinate system changes. So setup, new setup. I'm going to do the same thing one more time than in the last setup, but we have to now turn the view cube up on the right hand side here, turn the view cube around so that we are again in the bottom left hand corner. So the orientation is model orientation. Again, that's not quite right. Let's just see what happens if we use the box point. I'm going to select it, and Y and X and Z is this time right off the bat correct. So this is nice. And this is where we are going to have our work coordinate system anchored. The stock here is one important selection, and that is from preceding setup. So that is what we want, is a bottom selection right here, and we need to check continuous machining. So what does that do? Well, Fusion now already knows that at the bottom there is no stock anymore. We selected the stock box point, but of course we machine material off. So in the Z direction, this has now been corrected. So the stock and the model is at the same height at the bottom actually, and you can see that when we zoom in, we see that this one is here darker and this one is lighter in color. So we are actually machining this off, and the stock box point is representing the correct point on the model. Okay, so we already have the facing at the bottom, and that is easily replicated. All what we have to do is really right click, and then there are 2 options. One, we can say store as template. I'm not going to get into templates a whole lot, but templates are an awesome way, and I suggest that you research that topic and also have templates for a different toolpath that you always implement when you use or reuse a certain toolpath. So today I'm not going to do that. I'm just going to say copy, and I'm going to be under setup 9, and I'm going to say paste the toolpath. There it is. I open now setup 9. There is the face, and of course the face represents the wrong orientation of the model and the wrong surface. The tool is correct, and all what we have to do is now go in the selection of the stock, and it automatically selected the top. That's all what we have to do because the rest is already correct. And we can just say okay. This toolpath now should generate correctly. Well, it didn't. Dang on, what happened? Well, here we have the orientation again the wrong way. Let me correct that. I don't like it to go in the X direction. I like it to go in the Y direction, as I told you before. So we need to go into passes, and either now you can change it into from the 0 degree to 90 degree, or you can just say pass direction reference, and I'm going to click the Y axis again, and I'm going to say okay. So when it regenerates this, and now in our simulation is going to go. So here comes the next tip that I have for you. And that is, if we have to change, look at the view cube here on the top right hand side. We have a home button. The home will be this right here. If I now go to setup 8 and activate that, and I go home again, it flips it around. Do you see that? That is only because I have synchronized view cube with active setup. Actually, normally I have all 3 of these selected. So sync view with active setup and sync view with the cube. That is so important because this darn thing flips around on you. Anytime you hit home, it is in the wrong orientation. And it's very annoying. So this is one way to get around it. So I strongly recommend that you choose that setup. All right, let's go back to setup 9 that I have here. the facing and you see how it turned around. Nice. The next thing that we need to do after the facing operation is the channel, the vacuum channels. So both of these channels are going to use the same tool, and therefore I'm going to combine them in the geometry because they are so similar. But before we do that, I like to do some housekeeping here. We said this is setup 8 and setup 9 and phase number 3, and this is just a copy of phase number 3. All of that gets too confusing. So what was the first setup? Well, it was the bottom, right? Well, let's call it bottom. That's just some housekeeping. And the phase, which phase was that? Well, it's the bottom phase. And setup number 9 here for me, this would be the top. And the facing operation would be the top phase. That will make everything so much easier later on. All right, let's create another 2D toolpath. We need a 2D pocket. It does not need to be adaptive clearing. Oops, need to select the right side one more time. 2D pocket. Good. So the tool is the facing tool. We need to select the right tool. I go to my local library. I'm going to choose flat end mill as a filter. And I have here an 1/8 of an inch flat end mill, 3.175. One is a compression bit, the other one is an O-flute. So the O-flute is the one that I'm going to choose. I'm going to double check here, 18,000 RPM, 1.5 meters per minute. Hey, that sounds pretty good. We can use that. In the geometry tab, we now need to select the geometry. And here's one thing I like you to pay attention to, and that is if you select the top geometry in the heights tab, you have to tell it how far you want to go down. So you have to know the depth of the pocket, but there's a way around it. If you choose the pocket itself, or the floor of the pocket on this one, and then also on this one, the nice thing will be that the depth is already predetermined, so we don't have to worry about it. Okay. The heights. All right, I'm going to do the same thing. So the clearing heights here, let me just run through that pretty quick and then I'll be right back. Okay, for me it's 5, 3, and 2 millimeters. The top height is a stock top. That is correct because we still have stock on the top. No, we don't. It's not correct because the top height is the model top. We already cleaned that off. All right, let's choose model top, offset 0. What's the bottom height? Well, the bottom height will be the selected contours. That's because we selected the pocket itself, the floor of the pocket, and there's no offset to it. That's correct. Passes. All right, so on the outer vacuum channel, I like not to cut that in one pass. The way to do that is then basically, well, here it has stock to leave selected. That's the first thing that needs to go. We don't want to leave anything. We can click the smoothing, that is fine, and with a tolerance of 0.1 to 100. But I like to click multiple depth, and then we're going to say, what is the maximum roughing step down? It's a 4 millimeter tool, or 3.175 actually. So let's say half the diameter is 1.5 millimeter, and that's what I'm going to select right here. That's a safe value, 1.5 millimeter. I have a finishing step down. Actually on the channel, I don't care. I don't need one. The rest actually here, even step downs. Yes, that is good. And I think the step over here is 1.9 millimeter. I'm okay with that as well. Let's go to the linking tab. Here on top, I need to change my safe distance because I changed the heights in the heights tab, and I changed it to 2 millimeters. And then in the lead-ins or leads and transitions, I leave everything as is. Now here in the ramp, there's helix selected. That doesn't work. With a 3 millimeter tool and a 4 millimeter channel, how do you plan on putting a helix in here? That won't work. So we need to choose zigzag. And the ramp angle is going to be 5 degrees, and a maximum step down of 2 on the ramp step down is 2 millimeters. I don't know how that actually works with the maximum tool step down of 1.5 for the pass, but I think I'm going to choose 2 right here. And the ramp clearance, that's going to be 1.5 millimeter. All of that should work. Let's scroll down. Did I forget anything? No, I don't think so. That's it. Let's click OK and see if we can simulate this. Here's our zigzag. And then we turn green on all of the surfaces that are already finished. And there's the outer channel, zigzag in. First the inside towards the inside square, then it comes back towards the outside. That's also why it is going in one direction and then in the other direction. Okay, so that works, and that is our channel. So here is absolutely no burr or fuzz on the plastic. So that cut came out really nice. Left with the same tool would be to create a 4 millimeter vacuum hole right in the center that you see here. But this is a bore function, and we also have the bore functions on the outside, so we don't need to make this video any longer than necessary. And I will show you the bore function making those M8 holes right here. 2D, bore. And we're going to do the top portion first. That is important. So we already clear some material out, and we're going to select same diameter, and it's going to choose both of the top portions. Heights, well, it's going to be from the stock top, the clearance. We can say model top here again, because the stock top is already gone. And I'll choose always 5 millimeter. The retract height is from the model top, 3 millimeters, and the top height is from the whole top 0. That is correct. And the bottom height is the whole bottom. That's also correct. Passes is a bit more interesting. There's no structural leaf. That's important. The angle here is 2 degrees. We can change that to 4 degrees right away, and that's still conservative. You can use more if you want to. We need to select multiple passes so that we don't leave a section in the center. Number of stepovers is going to be 2, and it's 2.5 millimeter. Remember, we have now a 5 millimeter tool. That would be half the diameter. I'm okay with that. We need to click finishing pass. That is important when we have a bore function, because I think sometimes the interpolation of the bore is not quite as good. So that the bore diameter is correct and round. I'm going to check that, and I'm going to say 0.5 millimeter. We can make that smaller at 0.2. That will also work. Let's select 0.2, and we have a climb cut. Okay, there is nothing here that I'm going to change in the linking. I'm going to click OK. When we zoom into the hole now, you can already see that that inner diameter right here will not leave anything in the center, and that is important. So let's simulate this now. My computer is doing something in the background, and I have the other file open as well, so this might not work as well. Yeah, that is done. Of course, I didn't record the last section, but what I did is basically the same thing just for the lower portion of that hole. And what I did is I duplicated the upper toolpath. So you right click, say duplicate, and then just paste that in. Now what you have to be careful when you do that is that anytime you duplicate a toolpath, make sure that this hole is much lower than the other one in the starting point and is different. So in the heights tab, pay attention to where everything is. So an alternate way of creating the step bore, so basically both of these diameters, is to select them at once. And that's what I've done here. instead of separating them out and select them first, the lower or the upper one and then the lower one, I selected both of these at the same time. Okay, let's see in our actual cutting how that is going to look like. Now left to do is the outer perimeter, and we're going to do that by 2D contour. Select the bottom contour again, that's important. There's a little red arrow, it needs to be on the outside. The tool is going to remain the same. The heights, I'm going to run through that just like we did this before. The only thing I like to point out on the bottom height, if you want to make sure that you go all the way through, and I have that glued down on the table with tape, I'm going to select an offset of negative 0.1 millimeter. And in the passes tab, there's a bit more meat here. There is a finishing overlap I like to use of 1 millimeter. And that makes sure that we, from the starting point, the finishing point is offset by 1 millimeter. So we overrun that actually by 1 millimeter. That makes so that we don't have a mark actually on the outside. We do need roughing passes because the outside perimeter is made on a bandsaw and I don't know really what that dimension is very good. So the maximum step over, I want to choose half the diameter of the tool. This is here in about 2.5 millimeter or 2 millimeter. Let's say 2.5 millimeter. And there's a smoothing deviation of 0.1. Number of step overs 2. We do need multiple depths. I'm not going to do that cut in one pass. So the part here is now 15 millimeters. And I think with a 5 millimeter tool, we can go maybe 3 step downs actually. So that would be 5 millimeter, but I'm going to just choose a little bit more. 5.5 is the maximum roughing that we allow, and it will then make a calculation of what it can do. There is no finishing step down. There's no wall taper angle. The approach will be along the wall. Rough final. That should be it here. There is no stock to leave. Make sure that that is in. Smoothing is always good because we have a radius here on the outside. On the linking, there's a safe distance I need to change. I knew that already going to happen. So it's 2 millimeters. And lead-ins, transitions, and everything here I'm going to leave as is. So now we can see that we are having several passes here. And it makes actually this way the finishing pass on every single step down. If you don't like that, you can also make the finishing pass as a last pass going once around. So I'm going to leave it as it is right here. I'm okay with that. It's going to gallop on the outside around quite a bit more than you need. Actually, you can make that cut much more aggressive, but remember my tool is a little bit long. My tools stick out. So I'm going to play safe and just let it run around one more time. Okay, let's simulate this. And now let's have a look how this looks like when we actually cut it out.
Well, that was long and dry, but hey, those are educational things and you are here because you do want to learn Fusion 360 Cam, and I hope you did and that this video provided you some insight. If either you're already working with it and got something out of it, or you're thinking of getting Fusion 360. All right, that was it for this video and I'm going to catch you in the next one. Take care. Bye.